Hi everyone, welcome back. In this video, we'll look into how round robin performance will be. So generally, round robin algorithm is going to work on the principle of time quantum, which means when you allocated a CPU for a particular process, it will execute for only respective time quantum and will give chance to the next process, right? So means the general criteria what we are going to follow here is we are going to follow the arrival time plus time quantum of the CPU, right? So basically arrival time approach you are following at the algorithm called first come first serve algorithm, right? So if you look into this round robin algorithm more clearly, if the time quantum value is very less, very less. I mean, if the time quantum is very small, very small, what will be the context switches? Context switches between the processes, will be more. Am I right? Yes. If we look into when the time quantum is more, I can say when the time quantum is large, context switch between the processes is going to be definitely less, decreases, right? So as context switches are more, what about like interactiveness of the process? Yes, interactiveness of the processes is more. In place of here, interactiveness is going to be decreased. Means I can say it as it is having poor interactiveness, right? Guys, in other words, if I say as it is works on the principle of time quantum, if this time quantum value is a large value, I can say some kind of infinity value, this round robin algorithm will be equivalent to first come first serve. Just think about it. Yes, definitely when the time quantum is large, definitely it will be equivalent to round robin. What about for small values of time quantum? We are losing the efficiency, right? So efficiency is going to be, or efficiency is negligible to achieve, right? So you have to choose the time quantum in such a way that it should be moderate, not too large or not too small. That is what you have to think here. Hope you understood this video clearly.